Hey Geometry, I've got a new video for you. It's over the content 6.5, and it's taking a weird detour. Instead of talking about triangle congruence, side, 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 angle, side, angle, angle, side, we're doing some more basic things, but that require us to kind of like link together pieces of information where it's not just a one and done. Well, you know what? You'll see after a few of the examples how this is going to go. So, first thing I need to do is to reacquaint you guys with some basic classification of triangles that you've probably seen in a previous math class, but it's not a bad idea to just go over it one more time. So you can classify triangles by their side lengths or by their angle measures. And equilateral triangles, they just mean that you've got a triangle with three sides that are all congruent to one another. So if you ever see something like this where the identical tick mark matches up all three sides, that's what an equilateral triangle should look like. An isosceles triangle means that two of the three sides are known to be congruent. So technically an equilateral triangle is a kind of isosceles triangle because two of its three sides are congruent. All right, so think of the word at least. At least two of the three sides are congruent for isosceles. Okay? And then scalene, that's where you've got a triangle in which none of the sides are congruent. So I wouldn't put a tick mark anywhere. In fact, I could say one tick mark, two tick marks, three tick marks, just to say, hey, those three sides are not the same. And you might want to write off to the side, all three sides not the same, two sides are the same, and then all three sides are the same, or use the word congruence better than that, okay? Biangle, if you see somebody say a right triangle, that means that it has one 90-degree measure in the triangle. That's all you need to be a right triangle. An obtuse angle means you need one angle that is greater than 90 degrees. So one angle greater than 90 degrees gives you an obtuse triangle. And then for an acute angle, or not an acute angle, but an acute triangle, you would have all three angles within the triangle be less than 90 degrees. So an equilateral triangle is a really good example of an acute triangle because all three angles are actually going to be the same measure since all three sides are the same measures. They're all going to be 60 degrees. So 60 is less than 90, it'd be an acute angle. So something that looks kind of like that. All three angles less than 90 degrees. All right, so now that we got that out of the way, let's check out the notes examples. So, number 1 and number 3 were the first two I'd like to start with. So number 1, you've got a 68-degree angle here and a 22-degree angle here. You can solve for this last unknown using the triangle sum. Okay, so the triangle sum says all three angles within a triangle add up to 180 degrees. So 180 minus 68 minus 22 gives you the unknown measure here. Now this happens to be 90, so you figured out that you've got a right angle right there. So when it says classify the triangle by its angles and its side, you would say it's a right triangle. You would also say that it's scalene. And here's how we know for sure that none of the sides are congruent. If none of the angles are congruent, then none of the sides are congruent. So it's a right scalene triangle. None of the angles, I'm going to get rid of this. are, and I'll just use the little congruent symbol, which means no sides are congruent. Okay, that's number one. Number three, we've got the 3 tick marks, so right off the bat we know it's equilateral. And I was just talking about how all equilateral triangles are acute. I will say this though, some people will categorize a triangle as equiangular if it's equilateral. So I'm going to put in parentheses, it's equiangular. You don't hear that stated too often, but I have seen it show up in some textbooks. So there you go. Classification, pretty basic. What about drawing them? Sketch the following triangles if possible. If it's not possible, just say so. So an obtuse scalene triangle. So here's what I want you to do. You got to be very specific. I want you to label both the sides and the angles to prove that it is both obtuse and scalene. So for number 5, we need to make sure that one of the angles is greater than 90 degrees. I'll just do that right now. And I'll make sure that this side right here is significantly shorter than this side over here that creates the greater than 90 degree angle. I'm going to call this 100 degrees. I'm going to label this side as well, you know what? I don't think we got to get too much into that. Here's all you got to do. 1 tick mark, 2 tick marks, 3 tick marks. Because I'm just thinking that if I name all the sides and give you the angle measures, it actually has to be accurate. So that'll do. Okay, number 5. Obtuse scalene scalene triangle. Number 7. A right obtuse triangle. So it's got to have a right angle here. And, well, hold on. If this angle is 90 degrees, then that means that the most that angle A plus angle B measure up to is 90 degrees. It's not possible to make a right obtuse triangle. So it's not possible. If not possible, state so. It's not possible. A right obtuse triangle is not possible. Okay. You win some, you lose some, right? Now, we're going to move on to number 9. This can be kind of scary because it requires multiple steps. Okay, but you only really need to know 3 things. 3 things. Sorry, I kind of spaced out there. So we've got 9 different angle measures that we need to solve for. So what's the measure of angle 1, angle 2, angle 3, angle 4? I'll just put this up here so that we can keep track of the angles we actually figure out. And then the measure of angle 6, angle 7, angle 8, angle 9. So the different strategies we need to employ here are just the basic rules are 1. Do we have vertical angles? That's usually the easiest one. These are the angles that live directly across from known angles if one line intersects with another line. So right off the bat, we know that 2 is 60 degrees. And, you know, there's a lot of intersections going on over here. However, it's I don't know if it's clear to you guys, but this ray intersects with this line, which means that angle 7 and this 55-degree angle have to be the same. So angle 7 has to be 55 degrees. So I'm going to get rid of 7, put in 55 degrees here. There's our first strategy. We've taken care of all the vertical angles we can. This doesn't really fit because it's a line segment that stops there, and this is just really wonky what we got right now. 2. Supplementary angles. These are ones that add up to 90 degrees because you take a straight line, which is 180 degrees, and you split it up into multiple parts. So what I mean by that is this angle right here plus this angle adds up to 180 degrees because it creates a 180 degree angle. A straight line is 180 degrees. We've talked about this before. So technically, angle 8 plus 55 degrees adds up to 180. So you take 180 minus 55, which is 125, and that's angle 8. Or we could have said that 55 degrees with this angle 8 has to add up to 180. Do we have any others? I think we do. Check this out. Angle 6 plus 70 degrees plus 55 also creates a straight line. So the measure of angle 6 plus the 70 degrees plus the 55 degrees has to add up to 180. So you could find the measure of angle 6 by subtracting 70 from 180 and also subtracting 55. So the measure of angle 6 is equal to 110 minus 55, which is 55 degrees. So the measure of angle 6 is 55. Now here's the last one. It's the triangle sum. If you have 2 out of the 3 angles inside of a triangle, you can always find the third one. So right here, I've got 2 out of the 3 angles. I can find the third one. Angle 1 is 180 minus 90 minus 60. It's 30. Right here, 60, 70, angle 3. Angle 3 is 180 minus 60 minus 70. It's 50 degrees. Angle 4 is 180 minus 90 minus 55. Should be 35 degrees. Angle 5. I missed one. I missed one of the supplementary angles. A straight line that has a 90 degree angle means it finishes out with another 90 degree angle. Angle 5 is 90 degrees. Which means we have 2 out of the 3 on the last one. To get angle 9, you take 180 minus 90 minus 55, which comes out again to be 35 degrees. So, I'll be very frank with you guys. I think the reason why this is so difficult is because people are so used to, I need to get the answer within 30 seconds or 45 seconds or a minute of the problem, of looking at the problem. you need to be patient. You need to ask yourself, have I used all of these strategies? And then just follow through with it. All right, I got 2 more examples, and I'm already almost 15, 16 minutes in the video, so might be a little bit longer. Stay with it. Keep the endurance. The directions on number 11. Let me erase this stuff first. And unfreeze. It says the variable expression represents the angles inside of a triangle. Find the measure of each angle, A, B, and C. Then classify the triangle by its angles. So this is basically saying we have a triangle, ABC, definitely not drawn to scale, in which 3x minus 17 is that angle, x plus 40 is that angle, and then 2x minus 5 is the third angle. So all 3 of them have to add up to 180, so you can find the variable x very easily by just saying, take 3x minus 17, add it to 1x plus 40, add that to 2x minus 5, okay? And that should all come out to be equal to 180. So the variable expression is going to be 6x. You take negative 17 plus 40, that's positive 23, minus 5, positive 18. And then you've got a pretty standard 2-step equation to solve after that. Take away 18 from both sides. Divide by 6. And it comes out to be 27. Now you might be asking, why are we solving for x? Didn't it say find the measure of each angle? X isn't the angle, but it does give us that angle if I plug it in for x, that angle if I plug it in for x, and that angle if I plug it in for x. So 27 is going to go in here. The measure of angle B, 67 degrees. I can plug it in here as well. 2 times 27 is going to be 54. 54 minus 5 is 49. Yeah. And then I can do one of 2 things. I could say take 180 minus both of these to get the last one, or just go back to the x and plug in the 27 there. This is going to be 81 minus 17. Comes out to be 64 degrees. So it's a triangle with 64 degrees, 67 degrees, and 49 degrees. Would you call that a right triangle? No, because there's no 90-degree angle. Would you call it an obtuse triangle? No, because it doesn't have an angle that's greater than 90 degrees. It's an acute triangle because all 3 angles are less than 90 degrees. So make sure you answer both questions, not just the angle measures, but actually name it. Following directions, it's important. All right, and then the last one, I don't have a lot of time to explain all the ins and outs of what's going on with these problems, but here's the quick and easy explanation. On number 13, if you ever get a triangle in which one of its sides extends as a ray, like this, you are creating 2 separate 180-degree measures here. All 3 angles here have to add up to 180. So 80 plus x plus we don't know must equal 180. But these 2 angles together also must add up to 180. So that question mark plus 3x minus 22, it has to equal 180. So bottom line is this is what's happening. if these both equal 180, then they have to equal each other. And if they have to equal each other, that means they share this question mark, which means I could say, well, I've got an equation. If I want to solve it, I could subtract that question mark from both sides and get rid of it altogether, which means 80 plus x equals 3x minus 22 is ultimately the equation we have to solve. And I just want to point out here that here's 80 plus x, here's 3x minus 22. This is the exterior angles theorem in triangles, which just means that the outside angle that's created when one of the sides keeps going must equal the sum of these other two angles. They just always add up to one another. So the answer to number 13, if I were to get the x's on the right, get the constants on the left, whoops. Gives me 51. And I think they were asking us to solve. No, it said find the measure of the exterior angle. Let's just be 100% on that. Yeah. So you would solve for x, and then you would plug it back in here. So it's 3 times 51 minus 22, which comes out to be 153 minus 22, which means the exterior angle is 131 degrees. So I guess what I'm saying is this work does not need to be shown by you when you do problems like number 14. You literally can just go with these outside angles, the inside angles. These two added together must equal the exterior. All right, I'm going to stop there because I know our endurance kind of lacks on these videos. 22 minutes is a long time. Thank you for watching the whole thing. Make sure you produce the notes if you want to get full credit for the assignment for 6.5. And thanks for watching.